9 to power x becomes 3 to power 2 to power x plus 33 to power x becomes 3 times 11 to power x equals 121 to power x becomes 11 squared is 121 to power x. Now we can rewrite 3 squared to power x as 3 to power x bracket square plus, we can separate 3 times 11 to power x as 3 to power x times 11 to power x. We can rewrite 11 squared to power x to become 11 to power x bracket square. Now, if we look at it very well, we'll discover that we have base 3 and we have base 11. So the best way for us at this point is to divide both sides by 3x squared. So that becomes 3 to power x to power 2 all over 3 to power x to power 2 plus 3 to power x 11 to power x 3 to power x to power 2 11 to power x to power 2 all over 3 to power x power 2. So that will be 1. Take care of the square, that will be plus 11 to power x all over 3 to power x equals to, we can rewrite this as 11 to power x all over 3 to power x to the power square. Now we are seeing 11 to power x all over 3 to power x to be common. So at this point, we'll say let P, assumption P equals to 11 to power x all over 3 to power x. So if we substitute for P as 11 to power x over 3 power x, that will be equals to 1 plus P equals to P squared. Now we'll take 1 plus P to right hand side. That becomes P squared minus P minus 1 equals to 0. We have a quadratic equation.
Oh my God.
Now this quadratic equation is not factorizable. So that means we have to use formula method, which says x equals to minus b plus minus the root b squared minus 4ac all over 2a. So that will be p equals to, b is the coefficient of p, which is -1. We have minus -1 plus -1 squared is also 1 squared minus 4. A is 1, C is -1 all over 2a. That is equals to negative times negative is 1 plus minus the root 1 plus 4 all over 2 because A is 1. So P is equals to 1 plus minus the root of 5 all over 2. Now the question from here is, how do we evaluate this? But recall that P is equals to 11 to power x all over 3 to power x. We can rewrite this in the form of 11 over 3 to power x. So therefore, 11 over 3 to power x is equals to 1 plus negative root 5 all over 2. At this point, the best we can do at this point is to take the logarithm of both sides to base 11 over 3. We take the logarithm of both sides to base 11 over 3, 11 over 3 x equals to logarithm 11 over 3. I will explain that all over 2. So from here, that gives us x log 11 over 3, 11 over 3 equals to log 11 over 3, 1 plus negative root 5 all over 2. So when the base and the index of a logarithm is the same, logarithm becomes 1. So we have x equals to log 11 over 3 as base, 1 plus negative root 5 all over 2. Final answer.